Where's computer stuff? What's up, Chavez? You gonna say something or what? Hello? Not. Oh,
Hello.
hello. May the 4th be with you.
Yes, sir. I said that in the chat.
Yes, sir. Nice. Did you draw that picture of you?
Right, that's not me. It's just a character that I draw. But yeah,
Well, do you realize that caricature of whatever that is, either A, has no pupils, or B, only has pupils?
wait, say again. I can't hear you. You're kind of breaking up.
I said that caricature either only has pupils or B, doesn't have pupils. One or the other.
It has peoples.
Does it only pupils? Because that's all I see, just dark spots.
Oh no, it's just no, it has no people.
Since I had that surgery on my eye just sits here and waters and waters, and it drives me crazy. All day long, I have to wipe tears out of my eyes.
Oh man, you're right.
Oh, I mean, I am what I am, right? What am I going to do?
Was it painful with the eye surgery or not
Oh
really?
my God, it was very painful.
I can imagine that.
I mean, they cut my eyelid off. I mean, I lost my, yeah. You didn't know, you remember I was walking around that patch?
I mean,
Yeah,
I have a hearing aid cochlear implant surgery, so they had to like, pull my skin out of the ear so they could put something inside
it
the
hurt like
eardrum.
crazy, didn't it?
Yeah, that's what I felt, and that's why I had to put myself into sleep before, performing the surgery.
Oh,
I
sure.
kind of felt
All right, be good. I'm talking to the kids in the room. I'm listening to.
Oh, it's okay. But
yeah,
yeah,
but it's the post-surgery that afterwards with all the swelling. And I can imagine with the cochlear implant, you have limited area or volume in your ear canal for swelling, right? So I'm sure your ear canal probably swelled closed, and then all that pressure was probably pretty extreme.
it is. That's why I had to do 2 times since I have both cochlear implant on both.
They did 2 separate surgeries, one for either side.
Yeah, I did. I got one when I was probably a month old. I can't remember. And then I got another one when I was in elementary 1st grade because I was gonna get another one.
Wow.
Yeah. Because it's really hard for me to hear both sides. Well, if I have one, I can only hear on the one side. But if I have both, I can hear our surrounding much better, which is really weird, but it how it works.
Gotcha. Hey, what's up, Cam?
Hey, Mr. Pope, is the revisions due on next Monday, which is the May 10th?
I think it's Tuesday, isn't it? What is May 10th? Is May 10th a Monday or Tuesday? It's a Tuesday, right?
Tuesday is 11th, which is we have to go in person for EOC history, US
Yeah.
history.
Yeah, it's the day before that. As a matter of fact, I was gonna start telling people if they want to go ahead and start turning in, go ahead and start turning in if they want.
Yeah, okay.
That's not a perfect copy of your picture, but it's not too, I think the people could recognize it. I should have given you a little more of a chin.
It looks good though. I'm not gonna lie.
I should have given you a little more of a chin. I should have given you a little more of a chin.
It looks better though. I'm not gonna lie.
Holy smokes. How was y'all's weekends? How was y'all's weekend?
It was good.
Yeah, what did you do? Huh?
Mine was good. I didn't really do anything.
Didn't really do anything. You're breathing. You're performing cellular respiration.
True.
Did you excrete?
Yeah.
Okay, that's good. Excretion meets the requirements line. It's nice to do a little bit.
What do you do with you?
I actually had a friend that died on Thursday, so I went to his funeral on Saturday. That's all right. I mean, I knew he was gonna pass away. It was expected. I didn't think it was gonna happen Thursday. I thought it would happen this summer. I got a chance. I went and saw him over Easter. And then I came home, and on Sunday I read the last of the IA proposals that have been submitted. All right, if you guys are, I know class doesn't start till 12:05, but it'd be nice to go ahead and start getting some answers to the do now. See what you guys have. Thank you, Alan. Thank you, Chavez. And I agree with you, Chavez. It has to be. Hey, Chavez, could you tell me why in the chat, why you think it's that answer? Why it has to be that answer? I'd love to know your rationale behind it. So the three of you guys in here, let's see what you guys think about this one. Thank you, Jalen. Thank you, Cam. Thank you, Lopez. Is that a question mark like you're not sure? Yeah, you can. So somebody asked, can I look up the definitions for these four things? Sure, if you can do it quick. Thank you, Tracy. Thank you, Terry, quite contrary. And we'll start at 12:05. I just want to see. give you guys a chance to practice. Those are the people that are on time. Actually, we'll go to 12:06. People have to be here at 12:05. Thank you, Aspen. What's up, tree? Aspen tree. Aspen's strong like a tree. Y'all seen Aspen? Aspen's strong. Aspen said he could whip the chrome off a trailer hitch. He's so bad. Aspen's so strong, he said he could whip the fire off coals. I already know. Y'all saw now, Aspen, I will say this, man. You coming up to school wearing a tank top, you're trying to show off, man. You gotta have more modesty than that. You gotta have more modesty than that. You can't do that. All right. All right, it is 12:05. Let's see if we can get these answers in by 12:06. Last person is was Aspen. Aspen got it. And by the way, you got it right, baby. You did great, Aspen. Come on, come on, come on. I need to move on at 12. I need to move on before 12:07. I need to do it. So drop your answers in the chat. This was a knowledge question. It's a little situation. You just got to know. Thank you, Medina. I don't know about your rationale, but your answer is correct, but I don't know about your rationale. So I want to work on rationale as well. It's okay. Let's keep working. Oh, Samba, are you on two? You're on two devices. You're on your phone and your computer.
Mr. Pope, yeah, I am.
Yeah, okay, cool. I am moving on with this question in 10 seconds. See how many others we can get. Right now, I'm at 87%. Correct. Good job, Chavez. Like, excellent job. 3 seconds. Romello, almost. I mean, we got, let's see if we get some more. Okay. So let's look at this. So I'm going to actually write this one out. And thank you, Tubbs. I see you guys still answering. I'm going to put a vocabulary list out here for you guys to study in a moment, and I'll show you why. But let's graph this for a moment. Let me just graph this. We're going to be working with data today anyway. So I'm going to put on my, what would be my independent variable here? Well, my independent variable is going to be, let's see, let me move this out of the way. Polluted area, okay. So it's acid, right? So we've got acid. So the pH of the soil is going to be it. So the pH of the soil. So let's say the soil is running from a 5, 6, 7, 8, 9, and a 10. This is just hypothetically speaking. It doesn't give us any numbers, but let's just hypothetically say that's what it is. And we're looking here on the y-axis. My dependent variables is the number of individuals, right? So we're looking at the population, the number of individuals or a population. I'll even put that in parentheses, population. All right, and I need a key, so let me make a little key to this graph. This little dotted line will be the original population, original Kentucky Fried Chicken, and then we get the spicy. We get this is the new population. New population. So we got the old, the original, and then we got the new. All right, so we say that the acid tolerance is significantly increasing. So, and it's downwind. So let's say this is the original population. looks something like this. So the average, let's say this right here, this average, this is here at the average, and average is X bar. The average is about, I don't know, 8.25 for the original population. Now, we said that there was a shift for an increase for acid tolerance. They're getting more acid tolerant. Well, I know anything from 7 below is going to be an acid. And I don't know if you guys can see this all that well. You might want to expand your screen to full screen to make it a little easier to see. And then anything above a 7 is a base. So if they're increasing with acid tolerance, then acid tolerance, maybe the next population looks something like this. So now our X bar, or our mean, is going to, has decreased. So they went from X, maybe 8.25 to now a 6.75 in pH. This was a shift in one direction. So this was definitely directional selection. So if you said directional selection, you were correct. And it looks like I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I had 13 of you guys answer this question in 1, 2, 3, 4, 5, 6, 7. 7 of you guys were correct. So you guys started hitting me. Oh, no, 8. I'm sorry, 8. So 8 out of 13 were correct. So 8 divided by 13, what is that percentage? Somebody help me out with that. 8 out of 13, I'm going to say it's about 50.56. What is that?
Like a little over half.
Yeah, I want to know for sure. What is it? 8 divided by 13.
That's 61%. I just know 8 divided.
Yeah, okay, 61%, 0.61. So 61% of you guys got that one correct. We want to get a little higher than that. So just as a reminder, some things that are coming up, we got some really important dates. We've got 2 summatives in the next 2 weeks. So today is the 4th. So in 2 weeks from today, you'll have your evolution exam. So I'd start studying. Go ahead and start studying for that. Your IA revisions, it looks like some of you guys literally started to submit those. And if you want to submit them, go ahead and you've already revised it and submit them, go for it. Looks like some of you guys started doing that on Sunday. And that's nice. Kind of get what you need to get done. You don't have to wait till the deadline. You can go ahead and start submitting. Do remember, I am going to use, there is the IB, IA, there's the IA rubric, and I'm going to be using the exploration component, the exploration. I'll be using the exploration part of it. So this is going to be the part I'll be using to grade your revisal. So whatever you have revised, I'll be using this part of the rubric, the exploration part of that to revise your proposal. Both of these are summatives. And then we have a final exam. Mr. Rather will set that date. He has not set the date for it. It'll be the last week or so in school. And so there won't be any retakes. Remember, the final exam is the final exam. There's no retakes for that. So start studying for that. If I were you, if you go to BioPope on BioPope, this is my channel. This is my channel. So, and you guys know, all you got to do is just look on the videos. All the videos are there. And you just look at the channel. You can go back and start working from the last lesson to the most recent lesson. And I probably wait to do that till after the evolution exam and start recapping because you have the final exam coming in. All right, last time we were, so this is where we were. So today is a continuation of the last lesson. So we were selecting for trichomes. Remember, trichomes were those little hairy spots on leaves. We were selecting for trichomes. We were those little hairs that were all over leaves. And those little hairy structures are going with what we were selecting for. So if you had a lot of greater density, you survived and were bred. These were our constants. And then we had 2 dependent variables. We had density and we tested gene linkage. We also had a control group. And today we're going to analyze that data, which brings me to this question. Oh, what did I just say? I said no that way. But hold on a second. What is this crap? No one corrected me this morning. Now, I said no. Now that we, hold on a second. No. Now that we want, now that we know, why did no one correct me this morning? Now that we know, why did no one correct me? I was sitting here writing some crazy stuff and no one said anything. Now that we know what we're measuring, how can we analyze it? That's my question. I'm embarrassed that no one corrected me this morning. And so today we're going to use this. Today we're going to use this. Yeah. We're going to be using standard error and standard deviation. I know I had taught this to you guys last year, meaning literally last probably September, October. But I'm going to review it. So I'm going to go to Schoology real quick, and I'm going to show you guys where we are going to be working so that you know we're going to be using standard deviation and standard error. So here's the evolution unit. Here's where your IA proposals are. Oh, and by the way, let me just point out here, I have, there is a new document for you guys. This is where you're going to submit your revised proposal. It'll be right here. Your revised proposal is right here. That's where you'll submit that. And then I'm going to go back to our unit and I'm going to go to today. So we're testing selection. And we're going to use this document. This is homework. It is due tonight before midnight. Some people have already submitted it from the last class. And in fact, 13 of them have. You'll get a chance to maybe even get it done in class today. Several did. But today I want to start with watching a couple of little videos, and then I'm going to stop and answer you guys questions. You're going to want to take some notes. So especially the formulas, you might need to apply the formula in a little while, but it's more important that I'm going to show you some shortcuts. It's more important that you watch, and I'll point out how to do this with a spreadsheet. So you guys are going to be using spreadsheets today. So I'm going to start with the video. Here we go. And it's good that you have the videos linked.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct.
Hi, it's Mr. Anderson, and in this video I'm going to talk about standard deviation. When you're collecting data in a science lab, the amount of data you collect is important. So is the average, but another important statistic is going to be the standard deviation of your sample. And so in this video I'm going to show you what it is conceptually. I'm then going to show you how to calculate standard deviation by hand, and then finally I'm going to show you how to calculate it using a spreadsheet. And so first of all, what is it? Well, to understand standard deviation, you have to understand the normal distribution. And so what does that mean? Well, it's a bell-shaped curve. You might think of it like that. And so in the United States, most men are about 5'9". In other words, that's the average right here. That's the mean, or in statistics, that's the X bar. But there's going to be a lot of men who obviously are taller than that, and a lot who are shorter than that. And so the standard deviation is going to measure the spread or the variation in this bell-shaped curve. And so basically, if we were to go right over to here, this dark area is going to be one standard deviation above and one standard deviation below the mean, or it's going to be below the average. And there's something cool about that. About 68% of the individuals are going to be in this area. So one standard deviation above and below. If we were to look at this, for example, down here is two standard deviations. And so 95% of individuals are going to be within two standard deviations from that mean. And then finally, if we go way down here, 99% of individuals are going to be within three standard deviations of the mean. But the standard deviation is going to vary depending on the data that you collect. And so if we had two curves like this, so if this is one curve, and then we had another curve that looked like this, that data plotted on the same curve, this one is going to have a smaller standard deviation than this one. They're both going to have standard deviations, obviously. They're going to have amounts where it's 68, 95, and 99% of the people. But this one down here, since it's more spread out, is going to have a higher standard deviation. And so how do we calculate that? Well, the equation is a little scary. The scary part, it ends up being right here. So students are a little scared by that, the summation symbol. But it's actually
So I'm not going to have you guys, you don't need to calculate this on the test or the quiz. You need to just conceptually understand it. The other formula you will need to use, but not this one. So, but you should conceptually understand this. So do pay attention, and I'll ask you guys a couple of questions in a second.
Pretty straightforward. It's not that hard to calculate the standard deviation. And so let me show you how to do that. And so first thing you want to do is you want to have a data set. So here's going to be our data set right here. And to make this easy, let's say we just have 4 pieces of data, 1, 2, 3, 4, and 5. So you're collecting data, and this is the data in your data table. And you want to figure out the standard deviation of that. Well, to set that up, we're basically going to take the square root of the summation of this divided by the degrees of freedom. So that sounds a little bit scary. And so let's go to the scariest part to begin with. So let's look at what's going on right here underneath that square root. And so what this is, so if we go like this, the summation of x minus x bar squared basically means for each of these data points that I have, we're going to have to figure out what's right here. So x minus x bar. And so the first thing we have to do is figure out what the average is. We have to figure out what x bar is. Well, basically, if I add 1, 2, 3, 4, 5 together, I get 15. And if I divide that by n, which is the total number of data points, so in this case, n equals 5. So we have 5 data points over here. So if I divide 15 by 5, hopefully you can figure out an average. The average is going to be 3. And so the mean is 3, or the average is 3. So what we have to do is we have to calculate this value for all 5 of these data points. What does that mean? Well, right here we're going to use x, and x for the first case is going to be 1. So that's going to be 1 minus 3, and then we're going to square that. So what is that? 1 minus 3, and we square that is going to be negative 2. And if we square that, so that's negative 2 squared. And if we square that, that's 4. Let's go to the next one. Well, this is 2 minus 3, so that stays the same. So that's negative 1 squared. And so that's going to be negative 1 squared, or that's going to equal 1. If we go to the next one, that's easy. That's 3 minus 3 squared equals 0. And if we square 0, that's going to be 0. Go to the next one. That's going to be 4 minus 3. And so that's going to be 1 squared, or equal to 1. And then finally, if we go 5 minus 3, square it, that's going to be 2 squared, and that's going to equal 4. And so if you ever see the summation sign, don't be scared by that. It's not scary at all. It just means you got to do a lot of work. So for each of these data points, 1 through 5, I had to calculate what was in there. And then I have to add it all up. So I have to add 4 plus 1 plus 1 plus 4, and if I add all those up, I get 10. And so what's going to be inside there? It's simply going to be 10. So let's figure out the rest of my standard deviation. Standard deviation is going to be the square root. In this case, we solve this as equal to 10, and then we're going to divide that by n minus 1. So what's n? That's our sample size. In this case, it's 5, and so we take n minus 1, and that's going to equal 4. And so what is our standard deviation? It's the square root of 10 divided by 4, which is 2.5. Or if we take the standard deviation of the square root of 2.5, that's going to be something like 1.58. And so you're going to have to use a calculator to figure that out. Well, what does that mean? If we were to plot this data as a histogram, for example, this would be our standard deviation, 1.58. And so it takes a while to figure that out based on doing it by hand. And so if you want to, give it a try. And so here's.
Now, this is where you're going to have to pay a little attention, right? So we're going to be using a spreadsheet today. So, and he's going to show you how, and then I'm going to show you how, and everybody will be able to do it. Everybody was able to do it before they left the last period. So don't freak out. Watch this. It's really simple.
There's data set over here. And so try to calculate the standard deviation using this data set over here and try to do it by hand. I'll put the answer down in the description below the video, but I would give it a try. It's worth doing once on your own. And again, this is going to be our formula, standard deviation. And so try to do that. Try to do that by hand. And so I'll wait. No, I won't wait for you to do that. Pause the video, try to do this one, and I'm going to show you how to calculate this really, really quickly. And so I'm going to show you the spreadsheet shortcut.
Yeah,
And so
I'm gonna
how
look at the
do
shortcut.
you do
There
that in
we
a
go.
spreadsheet? It's pretty simple. So what I'm going to do is going to take this data and I'm going to switch over here to Excel. So here's the data right here, 0, 2, 4, 5, and 7. And so I've entered my data into different cells. And now I'm going to figure out the mean, just to show you how easy this is. To figure out the mean, I'm going to hit it equals here, and then I'm just going to start typing. So I'm going to type in average because the spreadsheet's not going to.
Now, what I want you to do is pay attention to the parentheses. Anybody that had trouble last class was not paying attention to the parentheses. You have to use parentheses. So when you immediately type, it's going to be equals and whatever you want, average. It's going to immediately give you the first set of parentheses, but watch what happens next.
Use the word mean. So I type in average and then I select my data. I hit a close parentheses, I hit end, and it's going to give me my average, which is going to.
So watch him. He closes the parentheses.
The spreadsheet's not going to use the word mean. So I type in average and then I select my data. I hit a close parentheses, I hit end, and it's going to give me my average, which is going to be 3.6. So if I wanted to know the average, there it is. If I wanted to know the median, for example, I could just type median and I could go down like that. And so spreadsheets are super simple. And so what are we looking for? We're looking for the standard deviation. So how do I do that? I just hit equals. I then start typing STDEV. Can you see how it pops up right here? Standard deviation. Parentheses, then I'm going to select that. And then I'm going to go like that. So what's the standard deviation? It's 2.7. What does that mean? We had a bigger spread in the second data set than we did in the first.
All right, so I'm going to minimize this. I'm going to go back to the website. Did it switch over? Can you see it? Well, I went back to the website.
You're back to school.
I'm back at school with you. Good. Okay, good, good. All right, so I've got the data for you. I uploaded the data. Remember, this is data that the students generated last year. So let's take a look at their data. And I'm going to talk about the things I like about the way they set it up and the way that what I don't like about what they set it, how they set it up. So the first thing is, this is how they formatted it. They have observations over here. They've got all their plants. They had a sample size of 10. Their sample size of 10 was okay. I would prefer you guys have a larger sample size. What was the sample size I was recommending on your revisions? Thank you, Matthew. Could you type it into the chat? You are paying attention. You got it right, baby. Yeah, I was recommending 20. 20 is going to give you more reliable data. The more times you see something happen, the more that you're comfortable you become with it, right? So the same thing with in science, we don't want to just do one trial. We want to do millions of trials, but you guys can't do millions, right? We're doing millions of trials for the vaccine, but not necessarily for a lab in a classroom. So 20 though, if you do it 20 times, you start to feel like this data could or could not be reliable, depending on what happens. So I like that they had 10, but I would have liked for them to have 20. This is not the tidy method, and I'm going to show you the tidy method the next class. But it's really great for the way they set it up for their data table when they put it on their IA for next year. It looks really neat. You get P generation. You see the F1s. You've got the columns are labeled. You know, it's very clear. Their units are up here. They don't have units next to their numbers. You can't put your units next to your numbers because Excel doesn't know what to do with it. You should just have numbers. Looks pretty good. It looks pretty nice, but it's not the way I would do it to analyze it. So we're going to analyze it one way today and another way on Thursday. Right now, I just want to know, can you use Excel? And another reason to do this is because this is a skill that you're going to need to use in college. And I don't want to just teach you things that you just need to know just for IB, but also need to know for college and subsequently also for the ACT. So you'll turn this in tonight. I'm going to go ahead and I'm going to do the first. I'm going to do the first two columns. I'm going to do largest cotyledon and then largest trichome. And whenever I change this document, it's going to change on the document for you, so you can go ahead and see what I've done. So the first thing is the mean. Now, when I click in here, I'm going to first put an equal sign. Remember, equals. And then I'll start doing average. Okay, and I can see where is it right here. I see it says average. I'm going to click on this. And then I need to highlight the data. Let me get that out of the way. Highlight the data I want. Here it is. It's nice. You can see I am at, it says B4, so here's B4, this is row 4, column B, all the way to B13. This is a column B, row 13. It took all that in. And then, Terry, what do I have to do? What do I need to put my? That's right, parentheses and enter. Easy. I don't have to sit around and write a bunch of crap, right? It's just clear and easy. Just stand mean. And there's a trick. Now watch this trick. You're gonna freak out. Hold your horses. You'll love it. See how I can hold right over this corner? It goes from a hand to a little cross. Click on that and drag it over. Ta-da! It gets the average for all of them. Pretty nice, pretty nifty, huh? Pretty cool. Y'all want me to do that trick again?
Yes.
Yes.
All right, let's do the trick again. Tricks are for kids. Okay, so I've got my average here. You can see there's this little box in the bottom right corner. I'm gonna hover over that box. Ooh, and then I'm gonna drag it over. And let go of it. All you gotta do is just let go. I'm just gonna hover, I'm gonna left click and drag over and then release. And there it goes. Ta-da! And so I've got the average for all 3 categories, my collodons, my trichomes, and my stomachs. Well, now standard deviation. Let's do standard deviation. So I'll put STDV, and I'm going to use S because that's what we used last time, just regular old standard deviation. This is a standard deviation of an entire population. They're really the same. I'm just going to click on beat up old standard deviation. Then I'm going to highlight all the data. That's left clicking. And then let's ask Tubbs, what do I have to do now? Oh no, Tubbs can't. Go ahead, baby.
Slide it over.
Oh, I gotta do something before that. I gotta do something. I gotta enclose this data with something. What do I have to put around it?
Parentheses.
That's right, parentheses. Click parentheses and then enter. Boom. Now here's something I hate. See how this decimal place is it's only 1 decimal place? I want to do the same thing there. So up here, I'm gonna click on this, and IB is really anal about this. They want you to be using a consistent decimal places. So I like the way that is gonna work. I would need to change the decimal place up here too. So I'll change that and eventually, let's just go ahead and do that. I make this 1 decimal place over, boom. I want all these decimal places to be consistent. So let's do that over here because I'm going to use that decimal, make it 1 decimal place over. Hold on, let's do it over here. 1 decimal place over. And you can see those are your functions for decimal places. Now, I can drag it over. I can get standard deviation for the next one. So let's do standard deviation. Bam, done. Now, you don't know what standard error is. So let me go back and get standard error. But before we do that, I need to ask, are there any questions so far?
Can you do the trick again? How you got 15.5? I wasn't paying attention on that part.
On right here, the average or the mean?
Yes.
All right, cool. I can do all of them really fast. Watch this. I'm gonna back up. I'm gonna do the whole thing again. Look at this. I'm gonna do it because. All right, so let's say I want to do average. Click. And then average, I type average in there. I see it right here, average, nice. Close parentheses, enter, done. I hover over the bottom right corner, drag over, done. Standard deviation, same thing. Click STD, you'll see I'm gonna use DVS.S, click that. Drag over all my data, all 10 plants, and close with the parentheses. Boom. Now I'm going to take this and I'm going to drag it over. Left click, drag over. But I hate my decimal places, right? These decimal places suck. So I'm going to get this and I'm going to change my decimal places to 1 decimal place. Same here, 1 decimal place. Same here, 1 decimal place. But IB is going to insist that you can see how it rounds it up for you, right? Like what, check it out. Oh, sorry. See how it's 0.67? Reduce that decimal place and then go ahead and it rounds it for you. These all don't have the same format. We want to keep the decimal place the same, so I'm going to increase my decimal place there. If I drag this over, it probably do the same thing there. It did. Ta-da. It's super easy. It's really not difficult. So you guys are going to do that, but I got to show you one more thing. Are there any other questions?
So when you put the stdiff, how come you chose the stdiff, put the S, but there's actual just says std? I don't know why. Is there a difference to it, or
There's slight differences, not any difference that's going to make any, not anything that's going to really make a difference. So I'm just using the regular standard deviation. I don't want to use any, there's like variants of standard deviation that you would use, but this is, we're just going to deal with the basic one, the regular standard old deviation.
all right, got it.
I'm sorry,
Your numbers second two are different from ours.
are they? I don't think so.
The rows like 21.
What are you talking about?
No, I don't know.
No, what do you mean? Tell me.
Because I noticed for the width of the largest,
Hold on a second.
so these are all the same, right?
Yep.
Okay.
You got the same thing, man. You're on the exact same document.
Okay, because I was looking at this one.
Which one?
This one.
Really? Refresh it. Huh, I guess because you opened it before I did. And started working on it, so it didn't have my changes. All right, so if some of you guys went ahead and opened it before I started making changes, you weren't getting my changes at the same time. Okay, I'm gonna go back to Schoology. Did I go back to the page? Can you see Schoology again?
Yeah.
You can?
Yeah.
All right, here we go. Now we're gonna do standard error. Simple, easy breezy lemon squeeze.
Meet your next pillow. Why do we make our pillow in the shape of a cube?
Because you're an idiot.
I'll tell you.
Hi, it's Mr. Anderson, and in this video, I'm going to talk about standard error. Standard error is one of my favorite statistics, and the reason why is that it shows you how good your data is. And let me show you what I'm talking about. So let's say I collect two data sets. So this is data set 1, and this is data set 2. If you were to look at the data, you would say, well, this one over here seems to show more precision. It's going to have more data, and it doesn't seem to be spread out as much. But if I were to graph this data, so of these two data sets, if I were simply to create a graph showing the mean or the average of the data, both of them would be 12. And so if I had a bar graph, it would look like this for both data set 1 and data set 2. And so you should never have a bar graph if you're using it to represent a lot of data, unless it has error bars on it. And so how do you figure out what the standard error is? How do you make these standard error bars? Well, let me show you. So basically, I'll work through data set 2, and then I'll ask you to work through data set 1. I'll put the answer down in the description down below. And so to figure out standard error, the equation is really ingenious. Basically, all they do is they take the standard deviation and we divide it by the square root of the sample size. Why is that important? Well, what does standard deviation measure? Standard deviation is going to measure the spread, or how far the data is spread out. And so if you have a lot of spread, then you're going to have a large standard error. And the other thing it uses is the sample size. So the sample size is how much data are you collecting. If you collect a lot of data, and we're going to have a large number here, then that's going to decrease my standard error. Likewise, if I have not much data at all, that's going to increase my standard error. So let's get to standard deviation. If you don't know how to calculate standard deviation, or even what it is and how it measures spread, you're going to want to go watch a video. And so here's a little link I'll put to a video I made on standard.
You do need this formula. So you go ahead and jot this sucker down. I'll wait for you guys. I'll wait 30 seconds. Go ahead and get this formula. You're going to need this because the spreadsheet will not calculate it for you. Cam, you need a pen? Yeah. You will need this formula. Go fast, fast, fast. It's really simple, and I can write it again as well. It's not hard to memorize this one. And it's simple, like, I know you're like, what's up with all these letters? What's up with all these letters? This just means standard error of the mean. This means mean, this is error, this is standard error of the mean. That's it. I mean, it's not some crazy stuff. And of course, this is standard deviation, and this is your sample size divided by, or not divided, but it's the square, with this taking the square root of this sample size. Yeah. Thank you, Matthew. Matthew is going to be the other hemisphere of my brain today because part of it's dead. And Matthew gets this in spades. So when you get into that group, you guys want Matthew. He's going to be an asset. All right, let me get this crap off of here. And we're going to begin.
Standard deviation. So you could simply click here, or I'll put a link to the standard deviation in the video description down below. But you want to figure out how to do standard deviation. I show you how to do it by hand, and then I'll show you how to use a spreadsheet to calculate standard deviation very, very quickly. And then what is sample size? Well, sample size is going to be the number of trials that you do, or the number of data points that you collect. And so if we were to look at data set 2, there are 10 numbers over here. And so that means I'm going to have a sample size of 10. And so keeping those in mind, let me switch over to the spreadsheet and show you how I would figure this out. So right here, I'm in Excel. This is going to be data set 2. Again, I'm going to show you.
By the way, let me ask you guys a question. Which do you think, data set 2 or data set 1, is going to have the largest standard error? Will data set 2 or data set 1 have the most standard error? Drop it in the chat. Which one is going to have the most error? Data set 1 or data set 2 is going to have the most error? There is no 3. There's data set 1 and data set 2. There is no 3. Which one is going to have the most error? Oh my God, Matthew, just sit it out to everybody. Oh my God. Oh my God. Okay. Yeah, most of you guys are saying 1. Let's just see
How to do that one. And then here's data set 1. So what I'm going to do is, since I've got this column right here, I'm going to first of all calculate the average of that, or the mean of that. If you were to type equals MEAN for the mean, nothing will show up. And that's because spreadsheets don't use the word mean. They're going to use the word average. So you can see that that pops up. I'm going to put first I hit an equal sign, then I'm going to write in average and then parentheses. And now I'm going to tell Excel which kind of data I want to figure out the average from. I put it in parentheses, and it simply calculates for me that it's 12. Now here's a quick little trick. So I've done the average for this column. If I select this average and then I move my cursor down here, watch how it changes. So it changes from that to that. And so I can click it now and then just drag that over here. And Excel is smart enough that it's going to figure out, oh, if you want the average of this, now you want the average of this column. So you can see that the average is going to be the same. Now let me show you how to do the standard deviation. If you did that by hand, it takes forever. And so it's really important that you use either a calculator or a spreadsheet to do this. I'm going to hit equals, and then I'm going to start typing STDEV. That's going to be standard deviation. I'm going to hit a parentheses, then I'm going to select the data, and then I'm going to hit an end parentheses, and there's my standard deviation.
Okay, one thing. Watch when he did this. This is a mistake some of the kids last class were making. You don't want to take the average of this number here and the mean as well. You have to make sure that you're just going through these, just the data set. Some kids were trying to include this 12, which is the mean for the whole group, and it wasn't working. So let's watch when he does it again.
Really important that you use either a calculator or a spreadsheet to do this. I'm going to hit equals, and then I'm going to start typing STDEV. It's going to be standard deviation. I'm going to hit a parentheses, then I'm going to select the data, and then I'm going to hit an end parentheses, and there's my standard deviation. Now, if we were to compare that to the standard deviation of data set 1, so again, let me do that trick. I'm going to select this, move this over here.
1 was more.
You can see the data set 1 has a much larger standard deviation. That means it's going to have a greater spread in the data.
That's right.
But I'm going to figure out the standard error of this first one. So this is 0.825. And so I'm going to remember these numbers here and then switch back and figure it out. So let me write down the things that I need to know. So my X bar, or my mean, I said, is going to be 12. The N, or the sample size, we said is going to be 10 in data set 2, because I have 10 values over here on the right. And then the standard deviation that I just calculated is going to be 0.826. And I did that in Excel. So how do I figure out the standard standard error? So the standard error of the mean is simply going to be the standard deviation, which is 0.826. And then I'm going to divide that by the square root of the sample size. And the square root of the sample size is going to be 10. And so this is equal to 0.826 divided by the square root of 10. I'm going to need my calculator right here. And that is going to be 3.6. And then I have to figure out, so let me write that down. So that's 3.16. And then if I take 0.826 divided by 3.16, I get 0.261. So 0.261 is my standard error, or standard error of the mean. So you could figure out the standard error of the data set 1. Remember, in data set 1,
All right, so let's practice with the spreadsheet. So let's get rid of this. Does it jump back over to Cam? Does it go back to the spreadsheet?
Yeah.
Well, I was asking Cam, man. Does it go back to the spreadsheet, yo? It does? Okay, so help me work this out then. So I need to remember my formula. So let me put my formula here. And Cam, you're going to help me with this one. And then I'll get somebody else to help me with the others. So my formula again is standard error of the mean equals the standard deviation, which we have right here, 4, and divided by the square root of the sample size. That's my formula. So let's fill this in. So standard error of the mean, and you guys are about to do this on your own in a second. So here's my standard deviation for this one. It's 4.6 divided by the square root of n. Well, how many data points do I have? N equals the number of data points. That's where we got to get n. So n equals your sample size. Sample size. It's one reason you want a good sample size so that you can actually do some statistics. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So what is the square root of 10? What is the square root of 10? And oh, whoa.
3.16.
Whoa. I'm asking the Cam, man. Jesus, hold on, man.
My bad.
Cam's-
Sorry, I didn't hear you.
So what's the square root of 10, yo? Well, I don't know. You're going to have to use your calculator. It's going to be less than 10. Square root's always smaller than whatever the number is. So let me find my eraser and get this in out here. Boop. Square root of 10. And so let's do it. Standard error of the mean is going to be 4.6 divided by. You got your phone? I don't have my phone. You don't have your phone? Shoot. Dang, I wish you could. Hold on a second. My code is 10. All right, you got my calculator, Tam, so help me out. It's 3.16. What is 4.6 divided by 3.16? That'll finally give me my number. 4.6 divided by 3.16. 1.45. Okay. And since this is 5 is 5 or greater, so I'm going to say 1.5. So I need to clear all these drawings. He said 1.5, 1.5. Beautiful. Now, I am going to, how is that possible? How did the trichomes and the width of the cotyledon? That doesn't make sense. How is that possible? I see what you're saying, Matt.
So I'll
Matthew?
do all the exact same numbers?
Yeah, that doesn't make sense.
Yeah, I was doing it on my own.
That doesn't make any sense. So I'm going to revise all of this. Something doesn't make sense here. Does any, yeah, that doesn't make any sense. I'm going to go back. Oh, there they go. That somehow these
Oh,
numbers.
you must have copied and pasted.
That's what I did. When I drug it over, Taylor, you're right, baby. I copied and pasted. Thank you, Taylor Tubbs. Taylor Tubbs, yeah. All right. Okay, I'm gonna leave these numbers for you guys, and I'm gonna cut you guys loose to do this yourself. Let's see. I'm gonna go. Remember where the data is. You have your own Trichome data, and this is due before midnight. And the chances of you guys getting this all done before you leave here is great. 13 of the kids literally got this done in the last class within 15 minutes. And we have 25 minutes. I think you guys can get this, probably most of all of you guys get this done in a minute. What's up, Jalen?
So for standard deviation and for mean, do you want us to use one, or do you want us to just do it for all of them? Because when you calculate the standard deviation, it's all different, but you place them all as the same.
What are you talking? I don't understand what your question is. Explain.
Never mind.
No, say that one more time, because if you're having some questions, somebody else is probably having it too. I don't understand.
You said IB said you wanted us to use a consistent standard deviation. I was just wondering.
Oh, a consistent decimal place.
Oh, okay.
So all these decimal places need to be the same.
So to the nearest 10th. Got it.
Yeah. And I think what I screwed up a moment earlier was when Taylor Tubbs said, "Oh, I think I copied and pasted." And I really was just trying to get the decimal place to go over. So you're going to have to make it look like this. And yours is already. I've already done the first row. The only thing you guys have to do is calculate standard error, the mean, which you've got the formula. You can do it. You just saw me do it. And if you need to go back and check it out, you can. Other questions before we do this? All right, gotcha. All right, I'm going to put you in breakout rooms. And I'm only going to put you in 6 breakout rooms. So they're going to be a little smaller. Sometimes I put you guys in 8. Here's the other caveat. When you go in, I want you guys to talk to each other and say, who is the least comfortable with this? Whoever's least comfortable, you're the person who submits first. You're going to be sharing your screen and having everybody else talk you through it. I want you to get a little more help. I also want those people that are most comfortable to help them, because you think you may know what you're doing, but to try to explain to somebody what to do will challenge you to think about it a little more deeply and more thoughtfully. So that's the deal. The person who's least comfortable when they go in there is going to be the person that opens the document and submits it first. And then you're going to go through it, and the most comfortable person is going to be doing it last in your group. You're probably going, in last class, most students got through 2 people in 15 minutes. It took about 15 minutes to get 2 people to submit. Does that make sense?
Yes, sir.
Okay, so let me ask somebody to repeat the instructions. And I'm going to ask, who do I want? Let's get somebody I rarely talk to. Reggie, give me the instructions. I rarely hear from you. Reggie, you're going to slow us down. Your groups, I need you to talk to me. It's shy or
Could you
not,
say
doesn't
that
matter.
again?
Reggie, what are the instructions when you get into the breakout room? Who's going to do it first? Who's going to share their screen?
The least communicate, the shyest person.
Right. And I'm not going to start preaching to you. I'm not a Christian, but I do understand some Christian principles, and some principles of Islam as well. And one of these scriptures is, what you do to the least of me, you do to me as well. So I really want you to think about this. I want you to think, I'm going to help the person who's least comfortable, because that is what you do to be a good person. Whether you believe in a religious philosophy or not, that's what you do. You help people. So you're going to go in there with this intention of being helpful and kind. And then you're going to go to the second most comfortable. You should probably get 2 people to submit. Now you've got 3 different data sets. You got to go to I just did F1. You guys, I mean, excuse me, the P generation, then you go to F1 and F2. You can get all three data sets. Are there any questions before we bust into a group? You're gonna have to do P generation, you're gonna finish P generation and then go to F1, F2. It shouldn't take long. All right, breakout room friends, here we go. Bust with the whippets, go, 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 go. Well, I know you're almost, but yeah. And bust with the whippets.
Hello? Who's least comfortable with it?
Thank you for taking the lead on that. Pam, how comfortable are you with this?
Hold on, hold on, let me find the video. Hold on, give me a second.
Hey, you're gonna be helping folks. Did you join the room? Oh, good. All right, so you gotta have microphone on, you gotta talk to them, see who's gonna be the least comfortable, most comfortable, who's gonna do it. You gotta have your mic on. Same thing, Terry, talk to these people, come on. All right, cool, so then she's gonna do that, so you follow it. Put your mic on, so you talk to folks. Don't chat. It just takes too long. Don't chat, let her go first, walk her through it. Let her share her screen.
Who's least comfortable with it? I know, but he doesn't, Mr. Pope doesn't want you. Mr. Pope doesn't want, like, the.
Mariella, did you just get here? What the heck is Mariella?
So yeah, you have to stop shaking. Ashley, do you understand? Good? Yeah, I can hear you.
Tam, she's talking to you. What's up?
Do you understand it? Okay. Alan? Yeah, I understand it. Yeah, it really is. Quite literally.
Jessica, are you there? They're trying to talk to you. Are you there or not?
True. Okay, you don't understand.
Did she say something? Tell her to share her screen.
Press
And
you.
she's gonna be the person to work for you. Let her be the first person.
Yeah,
Work
first
first
you
room.
understand, right?
And then after that goes the next person. Come on, we don't have time to sit on our hands.
Yeah. I think I messed up on one of them. No, I think.
Hey, guys, nobody sharing your screen in here. So whomever is the least comfortable, share their screen and let's get off the dime. We don't have time for this.
Okay, yeah, I got it. I'm on the last one.
Well, then I need the whomever's the least comfortable person to share their screen. So if it's Mermello, if you're already finished, you can help this person. So I need whomever that person is to do it. So either that or I nominate somebody. Let's go with Mukhtar. Mukhtar, I need you to share your screen and open it. Oh, somebody just talked to me. Okay. Mukhtar, share your screen. Let's go. Otherwise, I'm bouncing you guys. I'm literally going to bounce you guys out, like out of class. If you're not going to help each other, you're not going to be kind, you're not going to get this thing.
I'm trying, sir.
I know you're trying, but I need, so these other people, I'll bounce you to another group if somebody else isn't going to do it. You're on your phone.
So just share the screen.
Yeah, share your screen and let the other students help you walk through this so that you can see
Alright.
it before we
I'll
get done.
just share it then.
Thank you. Roger that. Roger that. All right, cool.
How do you?
What's that? Oh, you gotta put equal first. So you gotta time, you gotta have to go back, get rid of all that stuff in there.
You may ask first.
Equal,
You may ask me. Yeah.
equal, and find out.
Hey, Mr. Pope. Okay, 1 second.
I'll do that. Oh, that's you, right? yeah, click out of there real quick, just like. Is it still on there? Go finish average, just do ADE. Okay, now you see what's this average right there. Click on that. And the parentheses behind it. Parentheses and in it. Boom, got it. All right, I'm gonna go to the next group. What's up?
What are we doing stuff inside the?
You don't have to do anything with it yet.
Oh.
All right, let me go to the next group.
Okay, well,
Y'all finished?
yeah. Everyone in my group understood.
Lise. Okay, cool. Y'all are doing this. Excellent. That's Jessica Guetta. Nice.
Oh, that's-
Are y'all talking to her? Hey.
Yeah.
Okay, cool. All right, roger that. I just trust me out when I come in here, I see nothing but like Mike's mic or like everybody's got their mic off. Okay, y'all
Did
afraid of
everyone-
each other?
Does anyone?
Good luck ever getting a date. Y'all are so scared of each other.
Ask you, you good?
Yeah, you're doing standard error, which is gonna take a calculation. Mariella, which group are you in?
I don't know. It kicked me out before I entered the group.
All right, hold on. Boom, there you go.
Did everyone finish? Okay.
What up?
Hello.
Wake up.
Hi, Mr. Pope.
Hey, what's up?
From the standard error, when you put the equal sign, which one do we use?
You have to hand calculate standard error.
I mean,
Calcu-
standard deviation. I'm sorry.
Oh, just do, it'll say STDEV period S.
No.
Okay.
I can't watch the TV.
Okay.
Is that somebody yelling or is that the TV?
It's my TV.
Oh, good Lord. Well, turn the TV off. Jesus. All right. TV. Trip me out.
Oh, yeah.
I want to come. All right, Ashley, Matthew, who all has submitted from your group so far?
Oh, that's where we have to submit it.
Yeah, I need at least 2 people from every group to have submitted.
I'll submit, and who else wants to submit?
It's gotta be right. Make sure everybody's got it right. And bust with the whippets. Okay, let's see.
Oh, wait, okay.
Oh.
So you guys are on your F1 still?
Yes, I think.
Nice. Okay, cool. You guys are on your way. Who else has submitted so far? Abby, are you the first one?
I think so.
Yeah,
it's
just Abiel.
Oh,
Yeah,
bro. And Abby, you were the least comfortable with this?
I got really confused for a bit.
Who's been helping you walk through it?
Jalen and Donalia and everyone really.
Everyone?
Once you figure out the formula and what you need to do with it, it's relatively easy.
Yeah, and
Yeah,
then
I just kind of got some of them mixed up.
okay, and then I'm gonna have to, I need to get back to the conceptualization part of it in a minute too.
Okay.
Morrison, Corn Kids, you still there? You still with us?
Joseph's mic is busted as always.
Yeah, so he's struggling.
What? All right, I'm gonna jump to the last group. You guys could be good. Play in the street. My 1A, there's stakes in the mud. It's about as much fun as playing with glass in that class. These kids are not much fun.
Oh.
Who's sharing their screen in here?
Tristan couldn't share her screen, so we were just.
Well, who? Then that next person. Who else? Somebody needs to. People see people.
Mariella, do you want to share your screen?
I can't. I'm working on a phone right now.
Oh my gosh! All right, then E-Rail.
I'm kind of doing the same thing, but I'm good. Like
This is not going to work when you guys come to school on your phones. You're going to have to use a computer, man.
I can share my screen.
Yeah, do it, please. I mean,
My
whenever,
Wi-Fi is kind of unstable, but I can try.
yeah, people need to see this happen. We should have 2 people from every group submitting.
Right. Well, I was about to tell them of this trick you can do with slides if they didn't know, because it just automatically generates it for you.
Yeah, all right, I'm out. You guys have.
I think I'm finished. Tabitha, did you like put the stuff on the side?
Huh?
And bus with the whippets. Daniel? Hey, Daniel, which group are you in? Daniel, which group are you in? Daniel, which group are you in? Yo, Daniel, which group are you in?
3.
There you go. Where's my, oh, Cam's got my phone. I was wondering what my phone is. Don't worry about it. You need it to calculate standard error. Oh, I had the time of my life, and your mama never felt this way before. Yes, I swear. What? I got 3 people that submitted so far.
That's what I.
Awesome. Good job, Matthew. Good job, for real. Only thing you didn't do is to get your decimal places square.
Huh?
Only thing you didn't do is to get your decimal places consistent, but other than that, you did it. Good job. You did. It's the only thing you didn't get your decimal places consistent, but other than that, you were good. I'll point it out. I'm gonna use yours. You're set. You're ready to, for me, at least get the conceptualization part of it done.
Okay.
All right.
Everyone in my group already like understood it.
Yeah, y'all did. Y'all were definitely on top of it when I went in there. It wasn't that hard for you. It's good.
It's a present.
And owe it all to you. Oh,
He said mine Uriel's were correct.
I didn't check Uriel.
Oh, you didn't check Uriel's? Oh, okay.
The time of my life. And I never.
Alan, what did you get?
See how their group is talking to each other? Isn't that a novel idea? Okay, well, all right. I mean, it seems like a lot easier. You get through 2 people.
For which one?
His group got through 2 people, and now they're working on the 3rd because they're talking. I love Allow Classroom.
You divided what numbers? What did you divide? F1 generation. Okay. Oh, I think I know. I think I know what you did.
Oh,
No,
I heard it on before.
Okay, Alan, what did you get for
door,
the F1 generation, the standard error?
When you say, stay with me tonight.
The what? Okay, so the first column, sorry. Okay, yeah, he has it. Look, Alan got it. Let me see. F1 generation. Your standard error. Your standard error, you messed up on it, I think, because you're supposed to do you're supposed to put that number divided by the square root of 10. I think you put the mean. I think you put mean. What?
Wait, are we allowed to leave?
No, and if your group's done, but I was gonna say you had an extra minute. What do you say?
Yeah.
Can't close them.
You put the.
I can't. It won't let
yeah,
me
you
do it
take
anymore.
4.6 and divide it by the square root of 10.
Stand by me.
What?
Stay with
yeah.
me tonight. Stay
Yeah.
with me. Just remember.
I just put the
you're
entire
the
equation
one
in. Like
thing
I
I
put 4.6
can't
divided by the
get
square root of 10.
enough
Square root of 10,
of.
get the answer, and then divide it by.
So
Yeah.
I tell you some. Can you guys see my screen? Where it says Trichome data right here? You can. All right, roger that. Okay, welcome back, all you beautiful people. Let's see how many. Only 4 of you guys submitted. What? Don't let 1A punk y'all. All right, looks like the first to submit was Matthew, so we're going to use Matthew's data. And before I take a look at his, I want to ask you guys: does selection increase variation or decrease variation? And don't answer yet. I want you to think about it for a second. It's exit ticket here. I need to know, what do you think? Does selection increase variation or does it decrease variation? Drop it in the chat. Does natural selection increase increase variation or decrease variation? Thank you, Jalen. Thank you, Chavez. Keep it private. Thank you, Abby. Thank you, Mia. Does natural selection increase variation or decrease? Thank you, Reggie. Thank you, Eral. Thank you, Jessica. Thank you, Romello. Thank you, Tubbs. Thank you, Daniel. Daisy, Tracy, Mock, Elosa, Matthew. Okay, great. Now, Daisy, can you tell me, you're right, can you tell me why you think this? Come on your microphone and talk to us.
Because natural selection, basically, how do I say this? Basically stops certain traits from existing and like brings those traits to extinction.
Yeah, that's very well put. I don't know about extinction, but very well put. How do I say Mia more? That means that she loves me, right? Te amo, that's right. Te amo, Daisy. So well put. Selection is removing traits that are unfavorable, and that's going to decrease variation. Really good job. That is the thing. If you can recognize that, you've got it. You've got this in a bag. So let's just see. This is actual data that the kids did in class. Oh, Jesus, I love Te amo. So let's see. The P generation, they were selecting trichomes. Remember, trichomes were under selection. Trichomes are what was under selection. And we got, the average was 4.3. And look at that variation. There was a lot of standard deviation. Standard error was pretty high too. It was almost 1. And out of 4.3, that, and when your mean is 4.3 and your standard error is 0.82, God bless America. That's a lot of variation. So, I mean, you can see, I mean, look at this. You had some that were as much as 2 and some that are as high as 9. So they selected this one and this one. They took the top 10%. These 2 plants were bred together. All these others didn't get to reproduce. So this plant and this plant were the parents to these plants. Nice. And we got an increase in the mean. Look at that. An increase from 4.3 to 6, and that variation decreased. Standard deviation and standard error got smaller. They were on average a lot closer to 6, right? So you had the difference between 6 and 10 is 4, and you had some that in this group that were a range of 2 to 9. So that's a difference of 7. So yeah, the variation decreased. And look at that, what? And so we see which two plants. They selected probably this one and this one were bred together. And they produced these 10. And they didn't breed any of these. But look at the average. It almost doubled. It did literally double. 8.7, and still even variation decreased even more. We got 0.56. Yeah, but look at this. Was there any correlation in these other numbers? Were these genes linked? So 15.6, 15.5, 15.5. Cotyledons didn't change. Did the variation change? 1.7, 1.45, 1.47, 1.44. Nope. So let's see. For true leaves, the number of stomates, 4 and 0.22, 4, 0.26, 3.5, 0.27. Nope. Were these genes linked? Yes or no? Were these genes linked? Put in the chat, were these genes linked? Did it increase in, if they were linked, then if this changed, somebody asked, what do you mean? If they were linked, if I got an increase in trichomes, I would have got an increase in stomates and an increase in cotyledons. Did I get increases across all three phenotypes? Did I get an increase in all three phenotypes? No, you're right. Yeah, most of you guys are saying no now. Yeah. No, you're right. There was no link. There was no link. Selection did change trichomes, but selection for trichomes didn't change cotyledons or stomates. That was a pretty cool experiment, and the kids did really well on their IA on this one. Now, it took them 3 months to do this. I don't know that anybody wants to do this over 3 months. Oh yeah, natural selection decreases variation because of Daisy's explanation. Natural selection removes unfavorable individuals from a population. It selects those that have the best variation and removes the others. All right, I have to leave you guys. Don't leave yet. Don't leave yet. I need to take attendance. Hold on a second. Cam's got my phone. Yeah, man, what are you doing with my phone, Cam? All right, hold on a second. I need to get you guys. And I will, yeah, your numbers were correct. Hold on a second, weirdos. All right, now remember, you have to submit this completely done by midnight, and I will check it. You guys be good, play in the street. Don't let the, I will be in office hours if you need help. And I have the retake for convergent and coevolution today. So if you kind of take the retake at 3:15, come in. If you have some questions about this, I'll handle it after the retake. You guys be good.
Bye, Mr. Pope.
All right, play in the street.